Welcome to SanfordFlipMath. We are in Algebra 2. We are working through solving systems. Most of this content would probably traditionally be considered Algebra 1, but part of the Algebra 2 course is to review that. And we are working with systems of equations. We've talked about solving systems by graphing. We've talked about solving system by substitution. And so this is solving systems by elimination method. Just a quick reminder that the goal is to solve a system. A system is when we have more than one equations, more than one variable going on. And we are trying to find the set of values, usually x and y, could be x, y, z, could be a, b, c, d, e, whatever. The set of all values, or a set of values that make all of the equations in the system to be true. Specifically for substitution and elimination, basically our goal in those two methods is to somehow work the system down to one equation with one variable. So that's the big goal for us right now, is to work all of these equations and variables down to one equation, one variable, or one equation, one unknown. Okay, so that's what we're going to do. Elimination typically works with systems that are in standard form or something similar. Notice how all of the x's are in line, all of the y's are in line, all of the equal signs are in line, and all the constants are in line. So that's generally how you want it. I will say that just as long as you have one variable in line, you know, y's matched up with y's, it'll work. But ultimately you're going to have to pull everything to one side or another anyway. So generally standard form is what we want. And the basic idea of this is to just add the equations together. When I add the left side of this equation to the left side of this equation, and the right side to the right side, ultimately what I'm doing is, quote, adding the same thing on both sides of an equation. Just like if I had x minus 3 equals 7, I add 3 to both sides. Okay, to solve it. Here, these things, I'm sorry, these things are actually the same thing. X minus y is the same thing as 2. So when I add x minus y to the left side and this 2 to the right side, I'm adding the same thing on both sides of the other equation. Okay, so that's the why this works, and let's just do it. Okay, so when I do this, x plus x is 2x, negative y plus positive y is 0. So I'm not even going to write that down. And then 2 plus 2 is 4. We just got this down to one variable, one equation, and now I can solve by dividing by 2. It's probably worth noting that this system was set up, it was tailor-made to be perfect for this situation, for using elimination method. So this was obviously done on purpose. So the thing to notice here is that the y and the negative y have the same coefficient, but with opposite signs. That's the big deal. Okay, so things need to be lined up, and you need to have the same coefficient for one of the variables, but with opposite signs. So like negative y plus y adds up to 0. You want one of the variables to add up to 0. Okay, so let's work with one that's kind of a mess. Well, I don't see anything lined up in this. I really want the x's to line up, and honestly, 1/3 is not my favorite kind of number to work with. So I'm going to spend a little bit of time rearranging this equation, and I want to make it into an equation that's more like standard form, like this guy. I want my stuff to line up, x's, y's, numbers. I need the equal signs to match up, that kind of stuff. Okay. So let's make this top equation into standard form. Not a fan of the fraction, so I'm going to multiply it by the denominator on both sides, every single term, to make that denominator go away. So 3 times y equals, 3 times 1/3 is 1, and 1 times x is just x, and 3 times 2 is 6. Almost there, got the fraction gone. And then again, I want to have x's, then y's, then the number, so I'm going to subtract x from both sides. So negative x plus 3y equals 6. Okay, so this is now going to line up. So let me rewrite my system. Negative x plus 3y equals 6. 3x plus y equals negative 8. Well, I'm almost there. Here's the issue. Now, as I look at this, I see my x's are lined up, my y's are lined up, my equal signs are lined up, my constants are lined up. Don't fret the negative in front of the x because really we didn't care about standard form. What we cared about was x, y's, and numbers line up. Everything needs to line up. Now the issue is, if I add negative x plus 3x, I'm going to get 2x. If I add 3y plus y, I'm going to get 4y. This is not helping me because nothing canceled out. I need something to cancel out. Okay, so let's try this again. If this was a negative 3x plus a 3x, then my x's would cancel out. Okay, and I know some of you are saying, what about the y's? That's okay, that would work too. So let me just deal with the x's. I want the same coefficients, but with opposite sign. This already has the opposite sign. So I'm going to multiply this top equation by 3. When I multiply an equation by the number, I have to multiply both sides. So I'm multiplying all 3 of these by 3. Okay, so let me just kind of shove it over here. So negative 3x plus 9y equals 18. The bottom one is going to be positive 3x plus 1y, the same y, equals negative 8. Okay, now, am I going to get something that adds up to 0? I need a variable to add up to 0. So like negative 3x plus positive 3x, those go away. Hallelujah! All right, 9y plus 1y is 10y equals 10. Now I can finally solve for y. Remember, my goal was one variable, one equation. Yes, I have y. Okay, now I don't need just y. I need x also. Okay, so I'm going to take this y value, and I need to put it into one of the equations to solve for x. Okay, so that y value, and it honestly, it doesn't matter which one you put it into. It's entirely up to you. So I kind of like, I don't know, it doesn't matter. I could use this one, this one, this one, or this one, any one that has both x and y. So I guess I'll pick this one. It doesn't really matter. Okay, so 3x plus y. Okay, where did that negative 1 come from? Okay, so just a reminder that that was y. Okay, so now I can finish this by solving for x. So minus 1, negative 9, and then divide both sides by 3. This equals negative 3. So I have my ordered pair, negative 3, 1. And supposedly, this ordered pair will make both equations in the original system true. Now, I'm going to leave that to you if you want to check it, but we're going to leave it at that. Okay, now, I just realized that in my last example, I never found the other variable, so I do need to pop back and do that, and we can finish that problem. Sorry about that. So just kind of pop back to your notes on the first one. This guy right here. I found x, but I never found y. So let me put this into here. Again, it doesn't matter which one you put it into, just follow the equation you're using. Whoop, that was hilarious. There was not a 3 in this problem. Okay, so this is the x value, plus y equals 2, subtract 2 from both sides, y equals 0. So this solution is 2, 0. Okay, so this is now done. Sorry about that. Okay, I'm going to do one more. So let me pop back. So this original problem was set up, ready to go for elimination. It was matched up, and the numbers already added up so that one of the variables disappeared. This one wasn't ready at all. We had different arrangements. We had to rearrange and everything. And I would say normally I might do this one with substitution, but I want you to understand how elimination works. So there are going to be problems that aren't really ready for elimination that I'm still going to ask you to do elimination. Okay, just so you own that method. Okay, so this one's kind of ready, but it has a little bit of an issue. So the first thing again with elimination is everything has to be lined up. That's ready. The other thing is that I need numbers to add up to 0 for one of the variables. So like 2x plus 3x would be 5x. That's not 0x. Negative 4y, negative 5y is negative 9y. That's not 0 equals 14. Yeah, that's not so useful. Okay, so we need to force this to add up to 0 for one of the variables. I'm not going to generally get both variables to add up to 0. I mean, that could happen, and if that happens, then it's either they were parallel lines, no solution, or they were a single line, a million solutions. So what we're going to do is force this to add up to 0 for some variable. So like if I look at 2x and 3x, and why am I picking x? Just because it's up front. I could have picked the 4y and the 5y, the negatives of those. I would like to make these into numbers that add up to 0. So that means it needs to be like 2 and negative 2, 3 and negative 3, 6 and negative 6, 27 and negative 27, something like that. So I'm thinking in terms like a common denominator. I'm looking for a common multiple, a number that both of these go into evenly or nicely, and the smallest one is 6. So what I'm going to create is a 6x and a 6x by multiplying. But remember, I want one of them to be negative, and honestly, it doesn't matter which. So I'm going to multiply the top equation by negative 3. And remember, the reason is I'm trying to make them both 6 and one of them negative. So this top equation is going to be negative 6x plus 12y equals negative 12. Okay, I'm going to do the same idea with the bottom equation. And again, my goal is to make this front number 6. And I do want it positive 6 this time because I want it to be opposite signs with the other one so they add up to 0. So I'm going to multiply the bottom by 2. So again, I have to multiply both sides of the equation by the same number. So 6x minus 10y equals 20. Okay, so now it's time to add them up, I hope. Negative 6x plus 6x, bye-bye. 12y minus 10y is 2y equals 8. Negative 12 plus 20. Divide both sides by 2. This is looking like it's working. Y equals 4. Okay, I wish we were done. We're not. So again, we need to find x. Well, in order to find x, I need an equation that has x. So it needs to be one of these or one of these. And again, it doesn't matter which. They're all going to produce the same x value, we hope. Okay, so I'm just going to pick the top one. It doesn't really matter. There's no real rhyme or reason. I just had to pick one. Okay. If one looks easier than another, then feel free to use that. Okay, and so this is 2x minus 16 equals 4. I'm going to add 16 to both sides. So 2x equals 20, x equals 10. Okay, so the ordered pair would be 10, 4. Okay. I am going to take just a second to check it. Remember, if you're checking, you have to check it so that it makes which equations true? It has to be all. Okay, so I'm going back to the original. I want to see that 2 times 10 minus 4 times 4 equals 4. Well, this is 20 minus 16 equals 4. Yep, that worked. Okay. And then the bottom one, I should have done other colors, sorry. I did them backwards. 3 times 10 minus 5 times 4 equals 10. Remember, it has to make both of them true. So this is 30 minus 20 equals 10. Yep, that did work. Okay? All right. I'm generally not going to ask you, I'm not going to say simplify, or I'm sorry, I'm not going to say check. I'm going to say solve. And I'm going to just tell you that it's in your best interest to check just because you want to know that it's right. There are a million little places to make mistakes in this. And if you don't check it, you'll never know if you made a mistake. I mean, you can just be confident in what you did. I get that. But there is a possibility you made a mistake. I know, shockingly enough, Stanford even makes mistakes. As you remember back here, I forgot to go back and solve that. So solve for the other variable. So I had to go back and do that. All right, well, I'm going to leave it at that. As you know, you are fully capable of pausing, rewinding, watching this again as many times as you need to. You know this is not a standalone course on video only. If you need to ask questions in class, that's why we're doing this way. As we do work through examples, you can ask as many questions as you need to ask. Thank you so much for hanging with us. This is Sanford Flip Math. It's been awesome. Bye.